Good evening, students. So I am Madhuri from St. Peter's Engineering College. So as you know, we have discussing about embedded system subject. Okay, today we will see overall view of embedded systems and many more. Okay, so first the slide. Here we are showing an overview of the embedded system. How does the embedded system look? Means in the way of block diagram. It is an outer block diagram, outer structure of the embedded system. So what is an embedded system? An embedded system is a combination of hardware and a software. Okay, so software, it may be any software like Android or embedded C. Okay, and hardware components are ARM architecture, Cortex. Okay, and many Raspberry files. These are all we are using from the embedded hardware. So only hardware cannot be called as an embedded system. Only software we cannot call as an embedded system. So this is all we have discussed in the last videos. So embedded system is everywhere. Whatever we are using digitally now, phone, washing machine, micro oven, whatever, smart TVs, whatever we are using the smart digital services in our home appliances, they are all of embedded systems. It is having an hardware and also a software, right? So it is always an active stage, and still many more advances will come in the embedded systems in the future. So as the technology is increasing, we will have more number of embedded system components, I mean to say devices, which are very useful in our daily life and also in the industry purposes. Okay, so we have seen wide applications of the embedded systems also. It is used in office, it is used in medical, it is used in colleges. In colleges also we are using softwares for uploading an online classes, smart digital classrooms. Okay, these are all we are using, right? So embedded systems is everywhere. So now next we'll go to the overview of the embedded systems. So here we are using an embedded system with three major blocks: application, software, OS and hardware. So OS is the operating system, which is the bridge between the application software, means software and hardware. Between the software and hardware there is a bridge which is called an OS. Okay, this OS will be very suitable for uploading any type of software, whereas the hardware components we are using so whereas the hardware components where we are using is a CPU. So this is the hardware architecture of the embedded system. Okay, it is an internal diagram of the embedded system hardware components. In the previous slide we have seen there is a middle we have an OS, and at the outer sides we have a software, and also down is the hardware. So what are the components in the hardware side we have, which is very important, because once the hardware is correct, then only we can dump a proper software in it. Okay, so coming to the hardware architecture, so of course the hardware means always first of all a CPU, the CPU which we are using here. Okay, what is the use of a CPU? It will use for the arithmetic and logic units. We have a control unit for sending and any applications. Okay, arithmetic and logic units, it is a storing element. It will pass all the programs from one device to other. Okay, and it is a main heart of the computer, we will say it, right? We have already studied in the school wise, like a CPU is the heart of the computer. Okay, because this is the main device where all the programs will be sent and received to all the devices. So the CPU is very important, And for this we are of course the input device which we are attaching will be attached to the CPU, and whatever the CPU is giving, suppose we are giving any addition or subtraction operations as an input, the CPU will count and give you the number, right? So that's why it is always bidirectional. It is not unidirectional. Whatever the device which we are connecting to the CPU will be bidirectional maximum. Okay, unless until any device is fixed, it is unidirectional. Because if you see, for the RAM and ROM, which are the memory devices, for this it is only unidirectional. Because whatever the CPU is doing, the final will be saved in the RAM and ROM. So memory is always fixed. Okay, but if you want to erase the data, we can do in a RAM, but in ROM we can't do it. But still this memory will be fixed until we want to take it. Okay, so of course the battery will be there. Without the power no device will work, right? Input and output devices. To this we are having an application specific circuits. So this is very important, application specific circuit. Whatever the applications which we send in an embedded systems like embedded C codings and everything will be taken by this application specific circuit, and we will send the code related data in a block diagram wise, and it will send to the CPU. This application specific circuit is very important for sending the data which you want in an embedded C. Okay, next is the communication interface. Okay, communication interface is nothing but we are having some devices on board and off board. Here we are using mostly the microcontrollers and processors here. Okay, this SPI SCI is nothing but specific programming language. Okay, specific code instructions. So whatever the registers, instructions, okay, and specific programs, buffers, registers, everything will be stored in this communication interface. Communication interface is used for communication between the CPU and other devices for communication purpose, and some may be a on board, some may be an off board. Okay, maximum microcontroller will have an on board. Okay, and the processor we can add more devices in it. Okay, more external devices. So this all we can do in this communication interface. And this RAM and ROM, you know about these memories. Okay, there are two types of memories, RAM and ROM: random read only memory and random access memory. What is the difference between these two memory? We can only read only memory, only reading. We can't erase, we can't rewrite the program. Okay, whereas in random access memory we can read and also write. Okay, and also in this RAM we have a static RAM and dynamic RAM. That is depends upon the data which we want. We will use the type of process, static and dynamic RAM. Okay, so we also have another types of memory like ERAM, EPROM, EEROM, like electrical erasable ROM, electronic ROM ROM. So these are all the special categories in a RAM and ROM, but basic process we will use in a ROM and RAM. Always the RAM data should be more, because the code, see here, if you see, the ROM is a random, it is only reading, so it is a code language. So whatever the code we are giving as an input device for the embedded system, the code will be saved in a ROM. So code cannot be changed. If you change the code, the application will change and it will give the output different. So code is a standard thing, so code cannot be changed. So seeing that code only, we need to write the data, we need to send the application. So code is nothing but indirect answer. Okay, indirect answer of that applications, that we need to identify the code, read the code. How you know the code? When you know about the embedded C code, embedded C language. Okay, So that only you can read the code, you can understand what is each and every instructions given in a code. So that's why we can't change the code once the code is fixed. So that's why it is fixed, it is there in the ROM. Okay, so once that code should be converted into a data in a RAM. Why? Because we don't know the code. We need to change that code into a data. Then only we can send this data into other devices. Okay, because the other devices are not always aware of the code languages. Okay, sometimes due to the special applications of the code, the errors may occur. So whatever the code is there, we need to convert into a data that we will send into in a RAM for our reading purposes. Okay, so that is the difference here of using of memory of a RAM and a ROM. Okay, so this is the hardware architecture of the embedded system. Next we see embedded system and general purpose computer. So what is the difference between embedded system and general computer? General computer means whatever we have, laptop or general PC. What we do in a general PC generally, hmm? What we can do, the same difference. Embedded system ki general purpose system, what is the difference? General purpose means generally purpose what we are using. Generally what we do in a system, we will use micro, we will use Excel, Word. Hmm? We want to send the mail, we can send, or we want to play the games, can do play games, or recording we can do. We can download if we have a net. Hmm? We can prepare PPTs. So many things we can do. But specific purposes like coding, if you want to do any specific task, we can't do by using a general computer. For that we need to have a software for that. Suppose if you want to write a program in a C, in a general computer, first of all you need to have a tools related to the C in that. Okay, whatever the may be a code, whatever may be a domain, it may be a Java or a C or anything. If you don't want, we need to have a tools in the computer. So without tools, only just a computer is used for the basic purposes. Okay, so that is the difference between the embedded system. So where embedded system is not a general computer. Embedded system is a computer of having a specific task and specific software called embedded C software, and also it is having a special hardware devices like ARM architecture. It is having a Raspberry architecture. Their usage is different. General microcontroller microprocessor usage is different, which we are using in general purpose computer. Of course, the microcontroller processor will be there in every computer. Okay, without that there is no computer. Okay, but still, in order to have, if a computer can be say an embedded system, if it has a special software with special tools, and it will have much more fast data than compared to a general purpose computer. Okay, so this computer are two extremes, and here the embedded system can perform any task. Okay, any task. What are the any task? It may be send data, fetch data, decode, execute. We can run the data. We can, by using embedded system, we can run the home appliances. Using embedded system, we can get the data of a Raspberry file. These are all we can get by using only embedded systems, not for a general computer. Okay, so general computer, general purpose computers like your personal PC, your personal general usage. Okay, that is the main difference between embedded system and general purpose computer. Okay, so again this is the difference between the embedded system. So general computer, it is a combination of generic hardware and general OS of variety of application, whereas a embedded system, it is a combination of special purpose hardware and embedded OS. See, here we are using an embedded OS. There we are using a general OS. What will be the general OS? Microsoft, Micro Excel. We will use the advanced Windows 10 or 7. These are all the OSs. But here the OS are very different in the embedded systems. Okay. And operating OS operating is different. It contains general purpose. It does not contain OS. Okay. Alterations is applications are altered by the user. We can alter, because if you want this, don't want this software, you can change. Whereas an embedded system, it is not alterable. Embedded system means you should have an embedded C, you should have ARM architecture, you should have, it is fixed. You can't use by the other systems. It is fixed. Okay. And the performance level of the general computer is okay, slow, little bit, because we are not going to do many applications. Whereas for embedded system, we are doing many applications, so more power will be there. So it is also a fast, very key factors are very high. Okay, power consumption is more, there it is less. Okay, response time is not critical, and sometimes it is critical applications for some applications, because we are going to send many applications to that, so it may take little more time. Okay, so it's a 2 marks question. They may ask you what is the difference between a general computer, general purpose computer, and embedded systems. Okay, embedded system is a combination of hardware and software with a special OS, and a special hardware component called Raspberry or ARM architecture. Whereas a general purpose computer does not have a special OS. It is general OS like for micro Windows, Microsoft, okay, Excels, etc. Okay, and what is the examples usage of a general computer? For playing video games, for playing, doing some mail, we can do mail, we can write some, send some documents. General purpose for home, basic component, for basic appliances. Okay, whereas in embedded systems, we should have a code. We have to, by using embedded systems, we can operate the home appliances, we can write the code. It is used for fetch and decode. It is used totally for a technical device. Okay, so this is a basic difference of an embedded system and general purpose. Next we go to the history of the embedded systems. So where the embedded system has started its history. History is nothing but its birth. How the birth of the embedded system has taken. Okay. So first it was embedded system is first recognized in Apollo guidance computer. It is developed by MIT lab. Okay. So MIT is a very famous lab which is there in US. Okay, they have done small applications using this embedded system. Okay, this Apollo guidance computer have also designed 4K words of ROM and 250 words of RAM. So here ROMs and RAM and both are important, and the clock frequency of the microchip used in this was 1.024. Here slowly they are started using the embedded system, and they were testing with the small words, with a small chip, microchip. Okay, then slowly they have increased their applications in computing languages, and slowly they have used in ICs. Okay, and they have used in display keyboards. Okay, and in the calculator type keyboards with array of numericals. If you see in a railway station also, you will have a train number, right? If you see, observe the train number letters, if you observe that, it is purely of a digital, right? So if you see 1 2 3 train number 1 2 3 4 5 is in the platform number 1, they will be announcing. There will be a LCD screen there, if you see at the top of the platform. So if you see the numbers are not continuous, the 1 2 3, it will have, there is a distance between the digits, very minute distance will be there. That is because of the digital embedded systems which is developed. Okay, they're all digital works. That's why every number will have a code. According to the code, the number will be displayed, because the embedded system does not know what is 1, so we need to have a code for 1 2 3 like that. Okay. So first, the mass produced embedded system was guided computer for the minute end. So they're all they have produced embedded system with very mass in the sense large number of embedded systems with the guided computers. So finally in 1971, Intel people was the first person who did a microprocessor chip called 404, which is used for the business calculators, and it was produced by the Japanese company. So this was very hit microprocessor chip. At the time, people were using crazy about this calculators, because if for a business purpose we need to have a calculator, because we need to have many transactions, additions, subtractions. So if the count is more, so doing with the basic calculator takes a time. So here, the using a microprocessor chip, they have designed a digital calculator which they can calculate more number of high numbers within a very less time. Okay, and of course it was designed by Intel, but was produced by Japanese company, because producing means you need to have some money. So always the Japan is first in producing. Okay. Next, here again the MITs are also designed 4K of the fixed memory. So slowly they were increasing the size and memory of the RAM and ROM, and what is accessibility of their device. Okay. The accessibility of the device shows the reliability of the device. So and by June 1963, the figures reached 10K of fixed and 1K of erasable data. Then the final configuration was 32 kilovolts of fixed memory. And the clock frequency of the first microchip protocol model was in AGC, which was megahertz 1.024. Okay, so clock frequencies are very important. Clock frequencies are used for calculating each number of frequencies in a clock. Okay, so what do you understand by this? So here first they have evolved the embedded system. Slowly they have increased the size of the embedded system, size in the sense in form of their memory increase, okay, in time. And also they have slowly increased the features in it, and how they have developed the types of memories in that, how they have changed the configurations. So slowly it was done. Next, what is the purpose of the embedded system? What is the purpose? What is the use? I already won. Why there is no use? There is a lot of use, I already told. Okay, so very important. We have many uses. This use, whatever we are going to discuss, are related purely to the technical, our subject related technical. Generally, I told what are the applications in softwares they are using in college, we are using. These are all we have discussed. In medical, we are using, right? But how we are using technically, how the embedded is important technically for ECE students is very important. Okay. The first one is the data collection or storage or representation. So of course, the embedded system is designed for the purpose of data collection. Means it has a huge area of data collection of memory inside, and it can take the data and give the data to the external world. Okay. Here the acquisition of the data from the external world is very fast in embedded system because of the hardware which is there inside, and also the applications which are dumped into an embedded systems are highly fast. So they can take more data storage, it can perform, it can take any data, do some performance and give it to the external world. And storage is also more, collection is more, representing the data is also very good in an embedded system. Here when we are saying data, it may be a analog data or a digital data. Now everything in a digital data, right? Digital computer, digital camera, right? Everything in a code language. Okay, so all the data will be done by this embedded. We can have an analog also, but now the applications are more in digital. So now this embedded system is also working more on a digital circuits. Okay, next is digital signal processing. This is already we have this subject like generally. So what is a digital signal processing? When a signal has to be sent from source to the destination, what all the drawbacks, what all the disturbance which will happen between the signals will be controlled by using embedded systems also. Okay, so suppose we have some satellite communication problem in sending some data, signal problem is there. By using this embedded data we can rectify it. Okay, yes, for simple home networking systems also we can use it. Okay, here we are sending the data is achieved either by wireline or wireless, means wireless computer and wireline. So always everywhere here the data we are using is maybe a wire or wireless. Means what is the use of the digital signal processing is whatever the signals which we are sending digitally as an input, it has to be don't go to the output. When it is going, the digital data of the code should be verified. It should match with the output impedance. Then only we will have a good data, proper data with less noise, less power, more number of programs within a less time. That can be achieved by using a DSP, and also by using embedded systems. Okay, here also we may have analog, digital. Okay, if you take a Bluetooth, if you take a Wi-Fi, see Wi-Fi is the best example. So by using Wi-Fi, see once we fix the router and all, we are getting more data, we can transfer, we can download, we can send so many data, we are getting the signal properly. Okay, if it is really a good brand, it depends upon the brand, but we are getting a signal properly. By using these embedded systems, the advancements of this Wi-Fi has improved a lot. Okay, and using the Bluetooth, we are already having a Bluetooth everywhere. Okay, we can listen, we can keep the phone anywhere and you can listen by using a Bluetooth songs, right? So that all happening in the application of the digital signal processor in embedded system. Next is the data signaling process. Here the data signaling process like video, audio related. Okay, audio video related. Examples like for digital signal processing are we have a smart classrooms in our college. Smart classrooms, we will have a projector. We can read, we can show the video to you, and also we can explain through audio. And we can have a mic to that, and more number of people can listen using a mic. So here the speech is very important. The speech should be very audible. Okay, because if there are maybe 120 students in a class, but only original voice, it may be not possible. So I will use some device like a mic, and I will use a projector, so that using the projector many can see properly. I can increase the projector in the sense in the font size. I can show you very deeply. Whereas in a blackboard I cannot change this fonts and all, right? So if you want to, if I want to highlight any point, I can do by using a PPT on projector itself. This is all we are doing for a digital data signal process. Okay. Here a digital hearing aid is also an example for a employing data process. What is this digital hearing aid? Some people cannot hear, some ear problem is there. They have a machines which is kept near their ear. So that is the best example of a data signal process. Eardrum problem is there. Some people may not listen. Purely if they are dumb and deaf, if they are deaf purely, that will be not usable. If they are fine and their voice is not clear, others who are speaking is not clear, then they can use this data. Okay, that is called the digital data signal process. Next point is monitoring. Monitoring, of course, the embedded products coming under the medical domain are with monitoring. ECG, CRO. Okay, what is monitoring? Monitoring is nothing but we are going to see a particular device, how it is working. If you are taking a person, how it is, how the person BP is there, sugar is there, how the heart is, how the heartbeat is coming. I mean, what is the pulse rate? Everything we can do, we have to do monitoring, right? So this can be done by using this embedded system like ECG, CROs, digital multimeters, and logic analyzers. These all can be done by using this embedded system. Okay, so monitoring purely comes under a medical domain, which is used for the patients for heartbeat. Okay, next is the control. So control in the sense when any function has to be done properly, it should always have a control function also. Without control function, it will not be too successful. Suppose I am sending from data from source to destination and it is going very fast without any control of the speed. Then what happens? There may be error in the data or some data will be lost. So this all can be reduced by using these control systems. Okay. So here the control systems in an embedded systems, it contains of sensors and attenuators. So sensors are the control, right? Controllers, they are all indirectly controllers. If some overload is happening in any device, the sensor will start blinking, right? Some overload is there. Means it is giving a danger symbol to control some temperature or power or something. These are all control devices. So these are very important because we don't know what internally it is going correct or not. So always wherever we go, we have a sensors. Nowadays the sensors are used everywhere. Not only for the control, the sensors are used for opening the door, advanced architectures. Okay, so attenuators are nothing but if we are having any disturbances in a signal. Okay, if we are having a more high power of a signal, it can be stopped by using an attenuator. Attenuators are the stopping elements which will not allow the unwanted signal inside. Okay, unwanted signals will not be allowed inside if you are using an attenuators. Okay, so here we are using a sensors which is connected to the input port for capturing the changes in environmental variations, and attenuators we are using in the output port for controlling the changes in the input variables. right? Suppose we are sending any input. When you are sending an input also, we need to keep a sensors at the input side. Okay, the sensor will tell how much of data can be transferred from the input, depends upon the microcontroller and processor, because the person may not, sometimes the data we cannot see how much of data we are sending. If we are not having any limit in sending the data, at the time the sensors will start giving you some instructions, the data is more or the data is enough. Okay, so and what are the attenuators do? It is connected at the output side. It will see that the what are the changes happened in the input variables. Okay, these are very important. Next, the last application is an application specific user interface. Application, it was used everywhere: buttons, switches, keypad, lights, bells, display units. Okay, generally whatever the switch we have and all. And mobile application is the best example. Okay, what is a mobile application? Is provided with a keypad, system speaker, a vibration alert, we have a Bluetooth inside, we have a hotspot inside, we have apps inside. Okay, everything is there nowadays in the smartphones. So these are all the best example of an application specific user interface. So only the users who are we are the users who are using it. Okay, so this is the best application specific user interface for home appliances. Okay, and also the applications of the mobile phone, which are application specific user interface. Next comes to the characteristics of the embedded system. Actually the characteristics already I have explained. It should have less power, low weight, it should be portable. If you go to the previous slides you will see it. So once again I am having again a review of this. Okay, application and domain specific, reactive and real model. Okay, operations in harsh environment, distributed, small size and weight, power concerns. So power concerns is nothing but power should be very less and the power dissipation should be very less in an embedded system. Then only we can have we can say that it is the best embedded system. It should be a small size and weight. It should be portable. We can take anywhere. It should not be a too large size and it should not weigh too high. And it should be a distributed one. We can send the data to any people. Okay, it should not be a fixed like it is there in our device. It will not be there in your device. No. Okay, operates in harsh environment. So harsh environment is nothing but it may be a remote areas. Okay, it may be a very security areas also you should operate. Okay, then only, because you will be seeing so many films generally like some like robo and all, they will be using, they will be use of a, they will keep the chip of a robo in some place with some passwords and fingerprints, right? So that is the best example of this embedded system. So even how will be the temperature is there, it will be working, the device will be working. It should be a, and embedded system is a real time and reactivate. So always it should be a reactivate. Of course our embedded system is a real time embedded systems because we are using real time now. Okay, and it should have many applications on domain specific. So here the domain specific applications like getting the data, receiving, fetching the code, decode, execute level should be very high in an embedded system. Okay, so this is a basic characteristic of the embedded system. So in the next video we will see about the quality attributes of the embedded system, how the quality attributes will help the embedded system to run properly the programs. Okay, thank you. Signing off, Madhuri.